Hello, today we're gonna review kinematics of circular motion. You already have seen circle before in the course, and let's review a little bit of circle. Some language we're gonna use with a circle is a circle is a curve that's a equidistance from a point we call center. We'll label center with O. So from O to any point on the circle, we call it radius. And if you go from one end, from any point on one end to another end of the circle through point O, this is diameter, and we will label it D. If you didn't go through O, is some other point over to another point over here, that's not diameter, that's secant. We will not need that in this course, but the diameter is one end to the other end, and because from the center to this is R, diameter will be 2 times R. Another thing about circle is how far you go in a circle, how much distance do you cover when you go from one point to another point. So say you go from, say, point A to point B, then this distance A to B is called arc distance. So A to B it will call arc distance, and we will indicate this with letter S, or sometimes we're going to say SAB. Now, you could also say you went from A to B in another way. You can say with respect to this point O, you were in this direction. And when you went there with respect to point O, you were in that direction. So you can see that you can say this angle, which is here from our perspective, it is counterclockwise angle. So this angle, we can say we went direction OA to direction OB, and that is a we'll say arc angle, and we can label that as a theta or theta AB. Now if this radius is R, then there is a relationship between this arc distance and the angle that's covered, if you express angle in radian. So this is a famous formula, S equal to theta R, which is some other place is written as S equals to R theta. But we will try to write it this way, and you should memorize this, where theta is in radians, not in degrees, but in radians. So what's a radian? Well, a radian turns out if you go full around in a circle, so if you went in this direction and then this direction, you go all the way around back to the same direction, so you would have gone 360 degrees. But in radian, you would go 2 pi radian. So the same rotation of this line will cover 360 degrees or 2 pi radians. So this is the conversion. You can use a half angle, so half of the circle, that will be 180 degrees, and that will be just pi radians. This pi is an irrational number, and some of the digits are 3.14, and then it just goes on forever without repeating. And if you remember just 3.14, that will be useful for many problems. Okay, So if I were to write this formula, how much distance I'll go if I have a circle of radius r, I went from A and I went all the way around like that, and I came back to A back to A. Well, I would have gone a full circle, so that it's called circumference. So if you look at the distance I covered, circumference S will be, if you look at the angle, will be 2 pi radian. So if I use this formula over there, I have a 2 pi r. So the circumference distance that you may have memorized, that's just an application of this formula into. I can apply this to any other distance. So for instance, if you just went, say you were A and then you went, say, 30 degrees. So that's a B. So how far did you go? Say this was 30 degrees. So we will say, write down 30 degrees in radian and apply that formula. So 30 degrees in radian will be 30 degrees divided by 180 degrees times pi radian. And say if the radius was, let's call it 2 meters, then you can see that this one is 5 or 6 radians. So the distance SA to B will be pi over 6 times the radius, which is 2 meter, pi over 6 times 2 meter. And so radian times meter will be meter itself, and there will be pi over 3 meters. Okay, so you given how much angle you have gone, you can figure out how much distance you covered. You can go other way too. Suppose you have a circular path of radius 2 meter, and you ran and you went 4 meters. Maybe you went 2 plus 2. So say over here is 4 meters. So you went 4 meters on the arc. So what is this angle? So this angle we can figure out by using the same formula. So we have S equals to 4 meter you went. This thing is 4 meter. And R is 2 meter. Then this theta should be S over R radian. So we have a 4 meter over 2 meter is 2 radian. Well, you can use the radian conversion formula to get my degrees. So this should be equal to 2 radian times something in radian and something in degrees. So 180 degrees over pi radian. So this is 360 degrees over pi radian. So pi is 3.14. So let's say I just say 3 or something like that. So this will be 120 degrees. So the 4 meters is actually over here. Not up to here, but it's go all the way to there to get to 4 meters. All right. So so these are the properties circles we will need. In the next video, I'm going to talk about how to use this property circle to quantify the motion around circle. And so the next is motion